Welcome to Volleyball for CJ Just Physics. Since you're watching this video, we're going to assume that you want to learn how to play volleyball in the simplest way possible, and we're here to show you some tricks and tips on how to get the ball over every single time.
If you follow the following tips and tricks, you'll be guaranteed a spot on the CJ varsity volleyball team next fall. Let's get started! First off, we wanted to inform you that there's two different types of nets, boys nets and girls nets. For this demo, we're going to be using a girls nets, considering that's what we've been practicing with.
The volleyball court, a rectangle, is 18 meters by 9 meters. The net splits it in half, 9 meters and 9 meters, standing at 2.24 meters.
As volleyball players, we're aiming for the back, left hand, and right hand corners of the court because we want it to look like the ball is going out, but it's really staying in. If you hit the ball and it hits either the back line or the sideline, the point is yours. Think back!
Never, ever catch the ball.
If 4 players hit the ball in one play, the other team earns a point.
If the ball hits the ground on your side of the court, the point goes to the other team.
If you step over the line when serving, the point goes to the opposing team.
If you lift the ball, you lose the point.
When you first think about volleyball, ignore the idea of air drag. By having no air drag, it gives one less component to worry about. However, air drag is an important outside component to take into consideration because it affects the velocity, height, and displacement of the volleyball when in play. The air drag slows the ball down while gravity is pulling it down. So with those two outside forces combined, the ball will have a different flight pattern. Whereas with negligible air drag, we only have gravity as an outside force working against the volleyball.
The perfect angle to hit the ball at is 67.38 degrees.
Here is an example. Sarah is standing at 5'5". She throws the ball up and makes contact with the ball at its highest point that her arm can reach. She is standing 9 meters away from the volleyball net. Sarah needs for the ball to go up higher than the net, which is 2.24 meters.
Is this movie that I think you like? This guy decides to quit his job.
We derived this formula to help us figure out the maximum height of the ball so we can figure out how our parabola is going to work. By using the previous formula, we can help to determine the path that the ball will take. In this graph, the black line is the net's height, and the purple line is the path that the ball took for Sarah's serve.
Lady, running down to the riptide, taken away to the dark side. I wanna be your left-hand man. I love you when you're singing that song, and I got a lump in my throat 'cause you're gonna sing the words wrong.
There are 3 different types of serves: floaters, topspins, and jump serves. Floaters are serves that do not spin, they float. It is called a floater because it moves in unpredictable ways, making it difficult to pass. A float serve catches the air and can move unexpectedly to the right or left, or it can drop suddenly. Topspins are serves that spin rapidly from the top. The server tosses the ball a little higher, strikes the ball towards the top of the back in a down and outward motion, and follows through with his or her swing. This serve has much more predictable movement but can be difficult to handle because of its quick speed. In order to serve the volleyball, kinematics must be taken into account. It is very important to hit the volleyball at a certain height, d, a certain speed, v, a certain time, t. Timing is everything when you serve a volleyball. Additionally, you need to consider the acceleration from gravity on Earth, a, because that is how you will know when something will fall vertically. Any object that is tossed into the air, including a volleyball, has experienced projectile motion. When experiencing this type of motion, the effective air resistance is negligible.
We'd like to take a moment to have a little break to show this adorable little puppy! Sarah! We've just been handed these really important documents!
I've just been handed a very important document. In the aerodynamics of most sports, the ball has to spin in order to gain speed and height. This is better known as the Magnus effect. The aerodynamics of volleyball depends on a few things. The first being the stitching of the ball, which has to be asymmetric in order to create a flow field around the ball, which will result in the path of the volleyball being unpredictable.
Along with some of the notes that Sarah just received, we've learned that there's something called the Reynolds number. This device is used because it shows a pattern of airflow. This number is a fluid mechanic which allows engineers to abstract out a common mathematical problem for physical situations that appear to be different. An important feature of both Reynolds CD is that they are dimensionless qualities.
The force of the Magnus effect can be calculated by using the following equation. Fm equals SWV. In this formula, Fm is the force we are calculating, W is the angular velocity vector of the object, V is the velocity, and S is the air resistance coefficient across the surface of the object.
To further explain the topspin serve, when you hit the ball, it starts to spin, making the ball head downwards, which makes the other team not know what just hit them. Literally. Next, the floater serve, which often can be achieved with a jump serve, makes the ball not float, considering you hit it with the palm of your hand.
In aerodynamics, there are four forces of flight: weight, drag, thrust, and lift. As we learned in physics class, drag has to do with the shape of the object. The volleyball is a sphere, which means that it will slice through the air molecules quicker, causing it to move easily in the air. The mass is more condensed, as opposed to a sheet of paper, which does not have a nice round aerodynamic shape. Weight does not necessarily have to touch the object it is having an effect on, because it is a field force. Field force is a force in which two objects do not have to necessarily be in contact to be felt.
Weight is the gravitational pull on an object from the center of the earth. Everything is going to feel weight, including the volleyball, which means that the volleyball will eventually be pulled down. Lift is when the airfoil of an object can produce more lift than drag, keeping the object in the air. Thrust is what is propelling the ball, i.e. the force felt from your hand onto the volleyball.
Now you know the tips and tricks of playing volleyball. Now it's your turn to go out there and play.
Good luck!